Assalamualaikum and hi everyone. My name is Zahirah binti Muhammad Zairi and my matrix number is 1242514. Today I would like to present my SL assignment for financial mathematics, which is for question 1 and question 2. Question 1 is from chapter 5, which is loan, while question 2 is from chapter 7, which is yield rates. So now let's begin with our question 1, which centers on a home financing scenario for Amir and Sarah. They are acquiring a 300,000 ringgit property loan over a 30-year term at an effective annual interest rate 4.5%. What makes this financing model unique is its three-stage structure: an initial 6-month repayment holiday followed by a 30-month interest-only servicing period, and ending with a 324-month active amortization phase. To begin our essay setup for question 1, part 1, we will establish our inputs table. First, we convert the 4.5% effective annual rate I into a monthly effective rate J using the compounding formula, which is 1 plus I to the power of 1 over 12 minus 1, and then we will get our monthly interest rate, which is 0.0036748809. During the initial 6-month repayment holiday, 0 payments are made. The unpaid interest compounds directly into the capital. And to find our balance at month 6, we use this formula, which is 300,000 ringgit times 1 plus j to the power of 6. And then we will get our value for balance at month 6, which is 306,675 ringgit 0.72 cent. From month 7 through month 36, Amir and Sarah service only the interest, keeping the balance frozen at 306,675.72%. Therefore, when full amortizations begins at month 37, there are 324 remaining months. So to calculate the required monthly installment R, we use the PV of an annuity formula. But in SL, we use PMT formula, which is PMT J, and then our 324, and then negative with our balance at month 6. This will produce an exact monthly installment of 1,620 ringgit 0.83 cent. And then for question 1, part 2, we construct a fully dynamic 360-month loan amortization schedule using 6 standards column, which is period, payment amount, interest paid, principal repaid, extra payment, and outstanding balance. Okay, to make the schedule recalculate automatically without manual adjustment, we apply a nested if statement in the payment column. So for the period column, I use this formula, and then payment column, I use this formula. For the interest paid, I use this formula. Principal repaid, I use this formula, and then outstanding loan balance, I use this formula. Okay, here is how the underlying mechanics behave across the 3 distinct loan phases. On phase 1, which is accumulation phase, from month 1 to 6. During month 1 to 6, Amir and Sarah experience a repayment holiday where their monthly scheduled payment is locked at 0 ringgit because interest still accumulates monthly and compounds back into the core debt. The loan undergoes negative amortization. So for phase 2, which is from month 7 to month 36, okay, the borrowers are required to service only the interest portions generated by the loan, keeping their regular principal reduction at 0 ringgit because their monthly payment exactly matches the monthly interest charge, which is payment equal to interest. The outstanding loan balance remains completely flat at 6,675.72 cent across these 3 months. So for the month 37 to month 36, 360, the loan transition into full amortization as the regular monthly installment of 1,620 ringgit 83 cent officially kicks in to pay down both interest and principal simultaneously. As the principal balance decreases, the increased portion shrinks every month, and this will allow more of the payment to accelerate principal reduction until the balance reach zero in 360 months. So for question 1 part 3, where we model an accelerated prepayment strategy, the financing contracts permit single annual extra prepayment starting from year 2 onwards, capped at a maximum of 10% of the opening capital balance calculated at the beginning of each year. To maximize the time value of money impact, our model executes this 10% cash injection at the absolute earliest possible moment, the first month of every year, which is month 13, month 25, month 37, month 49, and so on. So in Excel, we automate the extra payment column using the logical test, which is we use this formula, which is if n period is greater than 13, MOD period minus 1, 12 equals 0, and then which is use this formula. So let's trace how this extra payment policy transform the 3 loan phases. So during month 1, which is month 1 to month 6, okay, no extra payments occur because contract rules restrict prepayment during year 1, so the balance compound to 306,675.72% as before. So for month 7 to month 36, okay, month 7 to month 36, while regular payments cover interest only, a major structural shift occurs at month 13, the start of year 2. The model automatically triggers the first allowable annual prepayment of 30,667.57, which is 10% of our balance at month 6, instantly dropping the balance to 27,682 is applied, reducing the balance to 248,407 ringgit 34 cents. This drastically lowers interest charge for the remainder of the servicing phase. And then for month 37 to 145, the standard 1,620 ringgit 83 cent monthly payment operates alongside automated 10% lump sum prepayments at the start of every tracking year. So this dual reduction mechanism creates a powerful financing snowball effect, wearing down the principal at an exponential rate. So our final closure, which is on month 146. During this month, the home financing structure is completely liquidated as the outstanding loan balance enters the final period at a tiny residual value of just 18 ringgit 31 cent. When the final month minuscule interest of 7 cent is added, the model automatically scales the final payment downward to match the total remaining liability of 18 ringgit 38 cent precisely. Paying this exact amount wipes the outstanding balance to 0 ringgit. So by applying this strategy, Amin and Sarah shortened their financing term from 360 months, which is 30 years, to just 146 months, which is 12 years and 2 months, saving 240 months, nearly 18 years of that payment. So now let's move to our question 2. On question 2, which involve a capital budgeting analysis evaluating two mutually exclusive projects, which is Project Zairi and Project Bakabali. So to evaluate this investment rigorously, we apply three core evaluation metrics in Excel, which is NPV, net present value, internal rate of return IRR, and discounted payback period. So for question 2, part 1, it needs us to calculate the IRR for Project Zairi and Project Bakabali, while the part 2, we need to calculate the NPV for each both project. So I combine for part 1 and part 2 of question 2 together. So for Project Zairi and Project Bakabali, the cash flow is already given in the question 2 info. This is the cash flow for both projects that already provided by our lecturer. Since it's already provided, I will just substitute into both table for cash flow. And then for the year, we already get the year is from year 1 to year 25. Now we need to find our discount factor. So for discount factor, I use this formula, which is 1 over 1 plus cash flow to the power of year. So and then we will get our discount factor for year 1 until year 25. Next is to find our present value. So the formula that I use for present value is cash flow times with our discount factor, and then we will get our PV for year 1 until year 25. Next is to find the net present value. On net present value for year 1, I make it equals with our present value. But for the next year, on year 2, I will use this formula, which is I take the net present value on year 1 plus with our present value on year 2, and then we will get our NPV for year 2. I apply the formula exactly to every year, which is from year 1 until year 25 for NPV. Okay, this is just the same goes to Project Bakabali, which is I use the exactly same method for Project Zairi and apply it with Project Bakabali, and then we will get for discount factor, PV and NPV for each project. Next, to find the, as we know, the interest rate is already given, which is 4.5% in the question. So I will find the NPV formula. The NPV formula is I use on the Excel formula, which is NPV, our cash flow, and then D4 is our for NPV formula, I take that our interest rate, and then I take all of the cash flow to get the NPV formula. But for the NPV sum of PV, I just use this formula, which is I sum all of the present value from year 1 until year 25 to get the NPV sum of PV. And then to find the IRR, I use the IRR Excel formula, which is IRR, and then I take the cash flow from year 1 until the year 25. Next, to know whether our project is accept or reject, I use this formula, which is if. So if you want to know either your project is accept or reject, first, if you want to know it is accept, we must know that the IRR is greater than the the interest rate. So if the IRR is greater than interest rate, then the project is acceptable. But If it is not, if it is otherwise, then it is reject. But for growth project, unexpectedly it is accepted because their IRR is greater than their interest rate. For both project Bakavali and project Zairi. Next, for question 2 part 3, they need us to determine the discount payback period. Okay, so to find the discounted payback period, I make this table, which is the last year with the negative balance is on year 16, which is this. And then absolute uncovered balance at year 16 is 11,656 ringgit, 12 cent. And then for total discounted cash flow in year 17 is 75,000 ringgit, 12 and 75 cent. So our discounted payback period, I use this formula, which is I take last year with negative balance, and then plus with our absolute uncovered balance at year 16 divided by total discounted cash flow in year 17, and then we will get our discounted payback period for project Zairi. And then the same goes with project Bakavali. It is also, we use the same formula. And then for discounted payback period on project Bakavali is 13.40. So as we can see, for question 2 part 2, we need to explain our answer on part 1, part 2 and part 3, and then we need to explain why, okay, which project is better. So to explain it is which one is better, so based on the result that I obtained on part 1, part 2, part 3, project Bakavali is recommended for the cooperation investment. Firstly, as we can see, the IRR is 10% for project Bakavali, which is higher than project Zairi, since both IRR are greater for the company, which is 4.5, and then both projects are considered financially acceptable. However, the higher IRR indicates that project Bakavali is expected to generate a better rate of return. And then second, I decide project the NPV. So the NPV for, as we can see, project Zairi is slightly higher than project Bakavali. Okay, so this indicates both projects are expected to create significant value for the company. And then finally, we will need to see the discounted payback period. As we can see, project Bakavali discounted payback period is smaller than project Zairi, which is this recovers the initial investment approximately 2.76 years earlier, reducing investment risk and improving liquidity by allowing the company to recover its capital sooner. So in conclusion, project Bakavali is the more suitable investment and should be selected by the corporation.